pen somewhere first, so it's not really worth it. Too much of an opportunity cost. Okay, I'm going to share my screen. Not that you need to see this super close, but I want you to be able to. This is my calendar and Outlook, and you can ignore all my doctor's appointments and all that fun stuff. What I want you to remember is there's no school Monday and Tuesday. Right? You know that. You're not going to tell Monday or Tuesday. Nothing going on those days. So because of that, I've moved due dates again to Thursday. So if you look at our assignments now, you should see I've put all of our due dates until spring break on Thursday. So we'll just kind of see how that works until then. I didn't want to be bouncing back and forth on you and having some things due on Tuesday and some on Thursday. So we'll stick with Thursday until spring break and then see where we are.
So the chapter 4 review questions is on.
Yep, so everything. So let me bring up the calendar in Canvas. I'm looking at a different class. Let me get this one. So in this Canvas calendar, I've not tried it, but you can do the calendar feed, like if you want to send it to your device. It's not super fancy, but it does allow you to select your different classes over on the side so that you can see things that are due for that class. So you can see today, I'm seeing something that hopefully you're not. It was, something that's not published. And then next week, our week 5 assignments will be due on Thursday instead of Tuesday in the following week. So if you just look at that calendar, you should see everything be on Thursday now. Now, sometimes in Canvas, I do have the end date set, which makes an assignment disappear to you guys, or at least the submit button disappear. So there's a chance that since I just drug these assignments in the calendar to a new date, I could have missed that. So let me know if it won't let you submit something that you're trying to submit. And we'll let you submit it. So we keep everything all going, making everybody learn stuff. Okay, so let's look at our unit exam. Now let's see, I have a couple of people that are going to take the exam today. So would you guys mind stepping out for a minute while we kind of look at these questions? You're going to take it late. We don't want to let you see the questions on top of it, although you can in the practice test. Still want them to see everything. Okay, so everybody did really good. I'm looking at the overall statistics. I think it looks really good for a computer test. Sometimes our scores can be low when we're taking tests. The Microsoft certifications, like for C# and the SQL Server that people take at the end of those classes, the passing score is a 70. So that's kind of a lower score for certification tests because our questions can be hard. They really can. They can be wide open. We had somebody get 98%. Woo, go. And we didn't have anybody really do that bad. So overall, an average of a B is a really, really good average. So I'm looking down through our questions, and I wanted to find some that we had some problems with and look at them. What about this one right here in the middle? Why is that one the right answer? What's wrong with it?
Because Lizzie can be a variable by itself. You don't have to set it to a variable.
Good thought. That's not what they're thinking though, but it is kind of hard to tell. So Lizzie should be, if it's a string, what should it have? These quotes, double quotes around it. But it really does look like a variable name. So again, that's why computer tests can be kind of hard to take, because you have to kind of almost be trying to think of what the test creator was thinking. Since they had strings and numbers that they were setting all these to, we just kind of have to imply or assume that they wanted that to be a string. So, but it definitely can be misleading. Let's see. Everybody really did good. We didn't all get all the same questions. We had just talked about modular programming just barely, so that was good. Okay, here's one. Some of these true false. Variable names must be created before a program can be designed. And that one is false. We don't have to have variable names when we're designing a program because we're just deciding what it's going to do. And I think there were a few in the test that were kind of back and forth about that make it a little bit misleading with what they wanted. What about this one? In a or an blank structure, there is a branch back to a previous statement in the program module. This was a fill in the blank. So if you notice, all three of those green responses were counted right. So that means in the right answers, over time, I've added some things. So it will take loop, it will take repetition spelt with the I in the middle. It'll take repetition spelt with an E in the middle, because I think our book kind of misspelled it some. So we have to be careful with that. But those fill in the blank ones can be super, super tough. So whenever you have the practice test, if it's not showing you the right answer, it's kind of like a worksheet. Use that practice test that way, like a worksheet, and go try to find that in your textbook so you know what they're looking for there. So that question is coming from the textbook, but like I said, I've gone in and added additional acceptable answers over time as people have said, wait. And then here's one that is an easy fill in the blank, but yet whenever you're looking at these blanks, I know it can make your head go completely blank. When you begin to analyze a problem in programming, the first thing you need to determine is the desired output. So we're always looking at what somebody wants, and that's how we decide what we're going to create.
On that one, I would say the book directly says you're looking for to determine your desired result.
Desired result.
So
well, let me add that in.
That's what I put in there
Okay.
because it said that exactly from the
Well,
book.
good job. I'll find that one and fix it and fix yours. So let's see if there's, the fill in the blanks are definitely the hardest. This one, tell me if there's a problem with it too in the same way, if you found something different in the book or something that needs to be adjusted. It says a programming error that results from failing to use the proper combination of statements to accomplish a certain task is a or an blank error. The answer they're looking for is logic. That's a program that is being able to run. It doesn't have any syntax errors, but it doesn't produce the right results. The next one, in a decision structure, there is a branch forward at some point causing a portion of the program to be skipped. And we're going to talk about decision structures today. So some of those early chapters take some looks ahead that can be kind of hard to remember when we haven't got there yet. Statements that are ignored or not processed by the computer are comments. Again, if it said something else in the text, let me know, because we are looking at a new text and there could be some changes. Programming is a cyclical process. After each step, it may be necessary to revise.
Yeah. On the comments one,
Uh-huh.
I had put in notes. Would that be acceptable or no, since it's not the exact term used in the book?
Well, we don't usually call comments notes, so I could see why that would be a good synonym. But as programmers wouldn't know for sure what it is. So some of that's just getting used to that terminology. And then like in the C#1 class, somebody came and wanted credit for a question, which is fine. And she had the answer right, but it was the word case for a case statement, but she put an uppercase C. And I said, no, because the programming language actually is a lowercase c. So it's that pickiness that we have to be concerned about when we're programmers. We're so picky and detail-oriented. But I think you guys did a great job. Good job. Let's get started on some decision-making. Our schedule over the weekend, since you're going to have some extra time, be working on your Chapter 4 review questions, kind of looking at that chapter, making sure that you're getting familiar with it, because we won't have as much time with it as we would if we had, you know, a whole week. Next week, we want to start using some Python too, and we'll only have one day. So we'll kind of merge our decision making and getting used to Python and stuff all together, and then see if we need a little bit more time before those assignments are due. Or we make it, maybe we can do some of them together in class if we need to. But over the weekend, be working on your Chapter 4 review questions, taking a look at Chapter 4, seeing what's going on there with that chapter. I'm going to start with this selection statements extra PowerPoint. I'm going to open my OneNote notes. And if you remember, we created those. We find mine for our class. And the last thing that I had done was insert the Chapter 3 PowerPoint. I'm going to create a new tab, new section here, and make this be the Chapter 4 PowerPoint special, because it's not the textbook one. And so then if you want to copy the textbook one into your OneNote notebook, you can do that too. But I want to grab this special one. So I'm going to open it in Canvas and download it. And then I'm going to drag and drop it on my OneNote notebook and tell it to insert the printout. Now let me know if you need some help with that. Getting it going. Do I? Anybody else not able to see Week05? That blocking somebody, something blocking you?
Yeah, mine's not working.
Is it not showing up? She's got it. All right. Now we can look at doing some decision making. We all do decision making all the time, right? I don't know why, but one thing that I always think of when I think of decision making is driving in Springfield. I don't know why driving in Springfield makes me think of decisions, but it's because of all those people that look at that light that just turned red and decide to go anyways. You know, that's a really big decision. We don't want our programs making illogical decisions like that, right? We want them to be making good decisions. I thought it was okay back there. Special pathway just leaving you behind. So decision making is important, and when we're working with computers, we could be making all sorts of different decisions. We might be programming robots. We're trying to decide, does this block belong in this pile, or does this block belong in this pile? That would be a decision that had to be made. We might be writing banking software at Jack Henry or something and have to be making decisions about, should this amount be subtracted from the balance? Should this amount be added to the balance? All those things are important decisions that we would have to make. We saw when we first started talking about flowcharts that whenever we have a decision, that's going to be the diamond symbol. So it's kind of a decision diamond. Whenever we have a decision in a flowchart, we're going to always have two paths coming off of it, our true path and our false path. It might be a yes path and a no path. Either way, it's the same. But we have to account for two paths if we want people looking at our flowchart to be able to follow the logic properly. Otherwise, there will be pieces missing. So whenever we're doing decision making, we have to have some sort of condition to base our decision on. You know, is the stoplight red? That's a condition. We're looking at it, and then we're basing our decision on that. Whenever we're programming, that condition that we are going to review has to result in a true or false value. That's a Boolean value, something that's only true or false. So in order to make these conditions, so we have a question? Heard something. In order to form these conditions, we use relational operators. Less than or equal to, greater than or equal to. Notice that is equal to is two equal signs usually. So two equal signs right together. Is not equal to is usually an exclamation point followed by an equal sign. And a lot of times programmers will refer to that exclamation point as a bang symbol. So you'll hear them say bang equals, I don't know why, but they do. So we're going to use these operators to form our conditions so that we can make a decision, right? So whenever we have our condition here that we're making a decision on, our condition has to have two sides, right? I have to have something to compare to something else. So I have to be saying something like, if A equals B, that's two sides, right? I have my right side and my left side, and in the middle, I have that relational operator, and then I can determine if that condition is true. Now, those operands on each side, they could be variables, they could be like strings, they could be numbers that we just typed in, they could be all sorts of different things. So we could have a literal value in a string, the number 42, whatever we wanted there to form our condition. Now this one is going to require some audience participation here. So I want everybody to play along or I'll get really grouchy. So in this flowchart and pseudocode, we have a condition. So in our pseudocode, if you notice, we put a decision is an if statement. So we have the keyword if, and then following that keyword if, we have some sort of condition. Something equals something else, something greater than something else, something less than. Then we have this keyword then. After the then, we do some stuff. Like in this case, we write out a message. When we're all done with the stuff we want to do, if this condition is true, we have a closing and if statement. And that's for our pseudocode. So let's look at that pseudocode. It says that we're going to declare a row number as an integer. And we're looking for row number 2 here. So that's you guys in the middle. So our if statement says, if row number equals 2, then row number 2, please stand. It's 8 in the morning, but stand up for me. Do audience participation look around at them and say, oh, good job, you guys. Are you not in row 2? Come on now. Stand up for me. She's not going to. God, I told you you're going to make me in a really bad mood if you guys don't participate. I'm going to be grouchy. I tell you what, really pisses me off. Okay, you guys get the idea. Now, we can't have something in our program not participate, right? Because this program is running using the certain data. If we have a condition like that, then we have to have some alternate processing to take place, right? We have to have some exception handling occur. So we'll talk about that as we get a little bit further on in our development effort as we learn things, but we always have to be concerned about that exception. Now, if we look at our flow chart here, we'll see we had the same thing. You guys don't have to participate for this one. We're going to declare our row number as an integer, set it to 2, then check. If it's 2, we want that person to stand. If it's not 2, we're going to say thank you. Now, notice if we ask them to stand, we are still going to say thank you. Now, whenever we're looking at a condition here, our order of operands can matter, right? It depends on what kind of condition we're looking at. For this condition, when we're looking at an equal condition, row number equals 2, then it's not going to matter, right? They're going to have the exact same results, whether we have the variable first or that number first. But as a programmer, when we code, we're going to prefer this format just because it's clearer for people to look at, that we're looking at something that's based on the row number. So if we are comparing to something that we've coded like that, then we're going to put it second. Okay, so looking good. Now we're going to have a less than condition, so we'll pick on this front row. I know they'll be good participatory people. In this condition, if we look at our pseudocode, we've again declared our row number. We've assigned a row number equal to 1. Now our condition says, if the row number is less than 2, I want row number less than 2 to please stand. So that would be you guys in the front row. So stand up for us, show them how it's done, turn around, wave, say hey, and then you can sit back down and we're gonna say thank you. Now, some things about this condition that we need to be aware of. Thank you guys. The test condition part of this if statement is in green. So this part right here is the condition. That's what we're gonna need to put into Raptor. We're not gonna put these other keywords around. So we always want to be aware of where the condition part is. Now, whenever we're looking at that condition part, we are looking for, remember, that relational operator. In this case, the relational operator is our less than symbol. Okay, so we're checking. Now, what about that condition? If we switched it, would it have the same results? No, right? Because if we're doing a less than or a greater than, we would have to swap that relational operator also if we switch the order of our operands, right? So if row number is less than 2 is not the same thing as if 2 is less than row number. So our order matters. We wouldn't have the same thing. Now, let's look at a greater than condition. Here, we'll pick on that back row. In this case, we want to set our row number to 3. And our if statement is going to be if row number is greater than 2. We're going to put out a statement, row number greater than 2, please stand. I could just stand really quickly, wave at everybody, say, hey, back there in the back. Now, when we look at this, thank you guys. When we look at this row number condition, row number is the left operand, right? 2 is our right operand because we're looking at those different right and left side of our condition. Now looking at our flow chart, notice again the flowchart hasn't changed very much through all of these, right? Because it's just the condition really that's changed. Because each time we've just tested for a little bit different of a condition. So most of our other code is pretty much similar. Now, whenever we're looking at pseudocode, again, our conventions are, we have the keyword if, followed by our condition, and the keyword then. Then we can have a whole bunch of statements if we want to, or one, or however many we need as things to have happen if that if statement is true, and then we have our end if. Now, question, the reason I wanted you to participate, and we'll look at a few more. The people that were standing were doing something because the if statement was true for them, right? What about the other people? Were they affected in any way? No, they didn't do anything, right? Because the if statement was not true for them. And that's how it is when we're writing a program. If the if statement is true, the actions are performed. If the if statement is not true, we just keep going and go right on past it. So we won't have any sort of action happen. Now, whenever we're looking at our flow chart, again, if we have a decision, we're going to have a diamond with a true and a false path. It's super important that we have arrowheads so that we know what direction our logic is flowing, because otherwise we're just kind of guessing. Okay, so we can have some different types of if statements. If you're looking at your OneNote notes, hopefully everything is in there that you need, but if you need to type something to get your mind to remember it, do so. Now, a single alternative selection means there's one if statement with one condition. That's what we've been looking at with our row number if statement. We have one alternative. You're in that row or you're not, right? So that one alternative. So this is a single if statement. We perform the if statement body, all of those lines of code between the then and end if, only if the condition is true. What if we want to do something if the condition is not true? Then we would add an else statement. So in an else statement, I'm saying, if this is true, do this stuff. Otherwise, do some other stuff. So we can think about that. That's a pretty standard condition, right? Now that's called dual alternative because there's two paths our code could follow. We could follow the if path and do the if statement body, or we could follow the else path and execute the else statement body. Said a condition had to result in a Boolean variable, either true or false. We can actually declare variables as Boolean so that they have values of true or false. So in this example, we have a Boolean variable that we're going to call brown hair. We can assign then brown hair to each person a value of true or false, depending on their hair color, right? And we could then do some sort of if statement that said, if they have brown hair, then write out that message, otherwise do something else. So look at that if statement for that Boolean variable. Notice in this case, it doesn't have two halves. It doesn't have the conditional operator because a Boolean is already true or false. So it's already got that value. We'll use some in our code so that you can see how it works. Now we can also have an else if clause, which gives us multiple alternative selections. We use this kind of structure for something like a menu system. So one place you might have seen a menuing system that you would think of as like an old, I've heard an older Xbox. Like when you start out, it would have kind of a character-based menu. You could do this 1, 2, 3, 4, or X. That's the kind of structure that lends itself to this else if, because I could say, if they picked 1, do this, else if they picked 2, do something else, else if they picked 3, do something else. And that gives me the structure I can use to check for all the different things that they might have chosen to decide what menu option to choose. Here's an example of that with the hair color, where we could use a code for somebody's hair color. We could use a code and say we're going to give them a code of 1 if they have brown hair, 2 if they have black, and 3 if they have other. Then we could have a multiple selection structure that said if their hair color is 1, we'd write out a brown-haired message. Else if their hair color is 2, a black-haired message. Else if the hair color is 3, we could write out to please select. And here's our else for our exceptions, where we would say, you didn't tell me, please select what your hair color is. So in this multiple selection structure, our final else gets executed if none of the else ifs got executed. Gets kind of messy. Does that make sense? For our multiple alternative. Now here's a multiple alternative kind of flow chart. You can see it starts getting a little complicated. That's why you'll see flow charts for small algorithm structures, but maybe not for great big giant ones because they can get a little unwieldy. But in this flow chart, we have decision statements saying, if their hair color is 1, write out that message. If it's not, if their hair color is 2, write out that message. If it's not, if their hair color is 3, write out that message. Otherwise, write out the message asking them to please select. So we can do all of those things with a multiple selection. Now, this is a really important one. You need to get this in your notes because this is a test question that everybody always gets wrong. The select case statement is a multiple alternative statement that exists in other programming languages. We don't have it in Python, so you won't get to practice with it. But there will still be a question or two here and there asking you about it. So it's something for you to put in your notes and remember the select case statement allows a multiple alternative structure. I can say, in the case that their hair color code is 1, do this message. In the case their hair color code is 2, do this message. In the case their hair color is 3, this one. And then I can have my final else as a default. So with Python, we won't miss this. It's not a problem to us. We'll be able to do our multiple selection because we can use else if clauses. But it means that you guys don't get experience using the select case statement. So that question here and there once in a while that pops up can be a little bit of a problem because we don't get to play with it. But it's worth it to get all of the other great Python experience. Now, the select case is super efficient, and that's why it's important in those other programming languages. We can tell it's efficient just by looking at this flowchart structure, right? So instead of having to redo those decisions over and over and over, like I had to with the if-else thing, with the select case, I can just check the hair color once and then choose the path I need to take based on its value. So it is more efficient than an else if, processor-wise. It keeps our processor happy. All right, so we've got everything there. What about complex conditions? Sometimes we have multiple things that we have to decide. We can use logical operators. Whenever we want to combine conditions into complex conditions, we can add things like and or, and then we can also use a keyword not if we want a negative condition. So let's think about it. I could say, I don't know, if you're shopping for a car, you could be looking for, you know, a Honda that is red. That would be an and condition for you, right? Or you could be looking for some, you know, a Toyota or a Hyundai that's silver. That could be an or condition with an and. So we do these kinds of logical decision-making processes in our head all the time. We just have to kind of narrow it down to what exactly happens. What all are we looking at? How can we get it down in some code? All right, so whenever we're looking at complex conditions, we might need to create a truth table. And a truth table just says, what are all the possible conditions based on this complex condition? Well, we have two conditions here. The condition of X can either be true or false. It's a Boolean. The condition of Y can either be true or false. It's a Boolean also. So if we create an if statement that says, if X or Y, the result of that will be true if X and Y are both true. Now, the result of X or Y will also be true if X is true and Y is false, because it's an OR condition, right? It will also be true if X is false and Y is true. So notice the OR is much more flexible. If either one of the X or Y variables are true, their condition will be true. Now, if we change that and we do an AND, it becomes much more exclusive. The only time X and Y is true is if X is true and Y is true. So we can see that the AND condition is much more restrictive. Both conditions we're testing must be true for the AND condition to evaluate to true. And then if we're doing a NOT, we just flip everything around and make it all backwards. If it was true, we make it false. So our NOT condition can be very, very effective, but can also be confusing. So we want to use it with caution. Only if it is a logical condition that really lends itself to that NOT operator. Okay, so let's do Raptor Flowchart. It's on page 217 of your book. If you have your book, we're going to do it together. So if you don't have your book, that's okay, but it might be easier if you have it. Let me get back to that page 217. So we have this program, a new car price calculator. So our program, we have a lot of requirements for, and we're going to create a Raptor flowchart for us because they're going to give us pretty much the pseudocode for it. We want to work on our flowcharting a little bit more. We need more practice. So this flowchart, this application that we're going to create, has decision structures, selection structures, and menus. So we'll be offering the user choices about things. So we are Universal Motors. We make cars. We compute the purchase price of the autos by taking the base price of the vehicle, adding in various costs for different options, and then adding shipping and dealer charges. The shipping and dealer charges are fixed for each vehicle at $500 and $175 respectively, but regardless of the particular model, the buyer can select the following options: the type of engine, the type of interior trim, and the type of radio. The various choices for each option and the associated prices are listed below. They'd like to have a program that inputs the base price of a vehicle and the desired options from the user, and then displays the selling price of that vehicle. So for our engine, we're going to have these choices. They can either pick 6-cylinder, 8-cylinder, or diesel. So we're going to create a Raptor flowchart, and we're going to offer them those decisions. They're going to type in this code depending on which one they want. And so if they choose the 6-cylinder with the code S, we're going to add $150 to the price. Then we're going to ask them which interior they want, vinyl, cloth, or leather. Again, we'll have a code for them to type in, and based on what they pick, we'll update the price of the car. We'll ask about a radio. It's kind of an interesting choice here. We're going to ask them if they want a CD, DVD thing, or if they want a GPS. So we're going to have all of these great choices. Now, we have some really, really clearly defined input and output. So remember with our IPO chart, we want to start out kind of analyzing that, making sure we know what is our input and what is our output. So our input that they mention is the base price, they want the engine choice, the interior choice, and the radio choice. after the user's entered an option, we're going to add to the price. So in our logic, we're going to really add to price based on these choices. So we could get much more specific in here. I want to kind of focus on these things that are our input. Now our final output is really going to be the car price. We might have other pieces of things that we want to display as output to make it more meaningful to the user, but this is the main thing that we're looking for in the end, is that revised price, so that we know how much this car is going to cost. So as you look further in your book, you're going to see that the things that we have fixed prices are shipping charge and dealer charge. Those are always the same, so we can set those up in our flowchart at the beginning as variables. Now they have kind of a hierarchy chart for us. So our program is going to be designed in this way. We're going to have a main module. From our main module, we're going to call the compute engine cost module. We're going to call the compute interior trim cost module, a radio cost module, and then display the selling price. So it's kind of like your bowling scores, where we can't just have one input module. We're going to have these separate ones that get different pieces of information for us. Now, as I mentioned, further on down in your textbook, you're going to see the pseudocode for all of those different modules as you go through. And we should be ready to just do our flow chart. We got everything ready to go. So let's see, I think Raptor's working on the computers now. You should be able to delete it from your H drive if you don't want it out there, but if you like having it there, that's fine too. But I think they got it installed. When I ran it the first time, I did get that weird message, and I don't know, I clicked something and it went ahead and actually loaded right. So I was super glad. Makes grading a whole lot easier for it to load properly than if it doesn't. So let's see, for our Raptor flowchart, we should start out with a comment. So I'm going to zoom in here a little bit. You can see better. Let me get a little bit better. So I'd like to have a comment here on my start symbol, because I want to kind of document what this flowchart is. So I can right click on my start and choose comment. And then I can type in whatever I want. I'll just say that this is the car price calculator. And then we should have some nice documentation there. Now, whenever we're working in Raptor and we want to make decisions, we're going to use the selection symbol. So let's try it a little bit in our flowchart here before we start going with our car price thing. The selection symbol is this one that is the second from the bottom. It shows the little diamond and it has some lines around it. Let's drag that onto your flowchart. Now, when you get the selection symbol on the flowchart, you'll see it has the true and false, or the yes and no paths. And so those lines are going to determine where you're going to put the Raptor symbols of the commands that you want to execute based on whether the decision is true or false. So where do we put our decision? We'll write in the decision symbol. So if you double click on it, you'll see it only has one text box area. And all we type in here is the actual condition part. So their examples, they say count equal x plus 2. That's wrong, isn't it? It should have 2 equal signs. Don't look at that one. Count not equal 5. These are the examples that they have. So we are just going to type our condition part. So let's say we are going to create a variable named count, like they have. Let's say we want to check to see if count is greater than 5. Now, if I run this right now, I should get an error, right? Because what is count? What's Raptor going to do about that? It doesn't know what count is. I don't know. I don't know how to come up with this decision because I don't know what count is. So if you get an error like that, it's because there's some sort of problem with the variable name. So, okay, I'll give it a count. I'm going to find my assignment symbol, and I'll drag it to, oops, it's going to make me save. Find my 120 folder to save. I always forget I have it on my H drive. I don't have much on my H drive. So I think I'm going to name this one Chapter 4 Car Price Calculator, or just Calc Raptor. And of course, I know the icon is telling you what it is, but it's still nice to have that file name that tells you. All right, so now I can change my assignment statement. And let's set count equal to 10. So now count is greater than 5. So Raptor should take my yes path out of my decision. So I'm going to put an output symbol on my yes path and just output count is greater than 5. And then we could actually output the value of count, right? We could do the plus count. Now try and run that. And you should see your variable gets initialized and set to 10. Then it follows our decision, and we get the output. Count is greater than 5, space 10. So it's maybe not the best output, but we can see everything. Is everybody's working okay? Working. Good. All right, so let's put something on the no path. I'm going to do another output over here. Of course, we could do any symbol we wanted. We just have to make sure it's on this line so that it runs only if the if statement were false. And we'll put something like count is not greater than 5. Plus our count variable. Now you guys are Raptor experts. You know we could change this to an input statement and prompt for count so that our flowchart would be a little bit more meaningful. But instead, let's just change our value of count. We're just testing here. I want to make it 4. Now when we run, Raptor should take the no path. Let's make sure it does. Start. There it goes. And so we get our message, count is not greater than 5. Now, if you want to watch it, remember you can slow it down a little bit more. So we start with the decision. Sometimes it's good to actually see it going that direction. So I'd like to have a message come out after the decision message. So I'm going to use an output statement and put it down here after the if statement. So this is basically after the end if, and I'll just output a message, decision structure has ended. Now if we run it, we should see no matter which path we choose on our if statement, our decision, we're going to end up with that last message printed out. Can make our count back to 10. And run. And we should see that decision structure. Now we didn't create this Raptor flowchart to save it. But if you'd like to keep like a copy of it, you could go to OneNote, and I'm going to open a new tab. And I'll make this one chapter 4 notes. And make this decision in Raptor. Now, whenever you're working with OneNote or Word, you can actually bring up that snipping tool, you know, the Windows snipping tool from the product. So if I go to Insert, I can choose Screen Clipping. And then I can just snip that visual of that flowchart into my OneNote notebook. Did you get it? You see where that is? Okay. So if you don't want to save it, that's fine. But if you wanted to keep it in OneNote, you can add a little bit of notes to that. Really good job. So in this one, we're using what I would call a hard-coded value, a hard-coded test value that we're setting our count to when we start out. So instead of prompting the user, we just put something in there, hard-coded it. And we do that often when we're testing as programmers, because sometimes it makes things a little easier. All right, let's do our car price one. This one I can delete all of the stuff out of. I'll just click and delete, delete, delete. I'm back to my beginning and ending, and my comment is still good. I want to make sure. Okay. Now, the new price calculator, whenever we're in Raptor, is actually on page 232. So that earlier page was talking about the application. On 232 is where they really start developing it. So we'll do that. Now, in your book, before the flowchart here, right before page 232, they do have a paycheck calculation kind of application for Raptor that you can run through on your own. It's a really good one if you want to try it. It's a little extra practice. So do take a look at that one, because I know you're going to be bored over the weekend and didn't give you enough homework or anything. So. Whatever you want to do. Well, let's start out. We have a whole bunch of variables that we're going to initialize in this flowchart. You know, we've been putting them in our main. But what if we create a subprogram just to create all those variables? Let's do it. Let's put a call statement on here. And we're going to call this subprogram variables. Just kind of get them out of our way. And yes, we want to create a new tab for it. Now, it automatically took me to my variables tab. So let's go ahead and create some variables for our program. We need quite a few of them. So however you like to do it, we need 1, 2, 3, 4, 5 numbers. So the first one is base price. I'll set it to 0. Then I want engine cost. I'll set it to 0. Then trim cost. Yeah, it's really our interior. I think they decided trim was a little bit shorter, so we'll take it. And then we need our radio cost. So remember, all of these cost variables are our numbers. The last number we need is selling price. Now, we're going to create a string variable to hold the choice the user makes for each of those options. So they're going to be named kind of closely. So the first one is going to be engine choice. and we're going to set it to an empty string with double quote, space, double quote. I know that's super small. So notice that the names are pretty close, engine cost and engine choice, the cost being our number, the choice being the letter that the user selects. Okay, trim choice. We'll set it to double quote, space, double quote. And finally, radio choice. And we'll set it to an empty string. Now we had those two numbers that they said never changed. So we have our shipping charge. And it is 500. And then we have our dealer charge, and it's 175. They decided after the original design that they wanted to personalize things a little bit more. So they're going to ask the user for their name and the kind of car they're interested in buying. So we need two more strings. We'll use our assignment statement again. The first one will be name. And again, it's going to be a string. And the second one is going to be car make. We'll set it to a string. Okay, so our variables then should be all done. Let's count. We should have 1, 2, 3, 4, 5 numeric variables for our costs and prices. We should have 3 string choice variables, our 2 kind of constant variables, and then our last 2 strings. Does that look good? Big item. Let's save. Raptor's really good about making us save when we're trying to run it. So when we're working on it, it's like, oh yeah. Okay, so now we're going to do our introduction. So let's go back to our main. And we're going to go ahead and put our output message in our main. So let's drag that output symbol right under our variables call. We want to enter something nice and helpful. So the book says, this program will help you calculate the cost of a new car. That you can personalize, of course. The exact wording is up to you, they actually say in our book, which is really weird. Never see them let us have any choices. Now, they say you might even want 2 output statements. You might think that it looks better with 2. Let's add another one before that one. I want it to be in between. And I'm going to make this one just be new car price calculator. It's kind of our heading. So if we were to run now, we should see all of our variables get created over in the watch screen. Bless you. And we should see our 2 output messages show up in the console. But we can wait to test for a minute because we have a lot of variables and it's going to run slow. Okay, so now we've got some nice output symbols in our main, welcoming everybody to our program. Let's go ahead and prompt for our input right here in our main also. So remember, we want the input statement. Remember, our input statement shows the arrow going into the symbol. And when we use the input statement, we have two things that we have to set. At the top, we have what our prompt is going to be. So let's make one. What is your name? And then we want to use that to fill our name variable. Down at the bottom in the little helpful window, Raptor does show you that you have a variable named name, so it can help you keep all those things together. Now, after we get their name, we want to find out what kind of car they want to buy. So let's use an input statement again. Let's do, what type of car do you want to buy? And this is going to be our car make. Again, I'm looking down here to make sure that it's the right variable name. And then our last input is going to be the base price. So let's use our input statement again. We're asking for input and say, what is the base price of this car? And that will be our base price variable. Yay, let's test now. We should see some nice input prompts. I do want to go a little speedier because I do have all those variables declared. We'll slow it down when we get to our logic. Now I'm going to run this. I should see it declare all my variables. Look over here in my watch window. They're going crazy. Then I'm going to get prompted finally for my name. And I want a Maserati. I don't know how you spell it, but I want it. I don't know, what is it, 200,000? 2 million, something. Okay, so now I can check in my watch window and make sure that those variables that I entered were properly set. So I've got my name here, the car make that I want, and that base price that I put in. Now, if they weren't set, remember, or if I saw another variable that had that value, I'd know that I'd made a typo in one of those statements. They have to be the same for it to all match up together. Now, as we go, we're going to create our different modules for asking for each of the costs. So let's start with our engine cost. I'm going to make sure I'm at my main module, which I am, and I want this compute cost module to go after all of these input prompts, right? Because we're going to use this input that they gave us in these modules, so we have to make sure that we already have this information from them. Remember that your order is really important. We can't use data until we've gotten that data. So let's see, we want to do a call, and we want it to go here at the very end, and we're going to make this one be named compute underscore engine underscore cost. And again, you can abbreviate a little bit. If you don't want typing practice, just make sure that you don't make it something that's not understandable. Now, once I click done, it should ask me if I want to create that subchart, and I'm going to say, yes, I do. So whenever we start with this one, we're going to be displaying like a little menu. We're going to be asking them which engine type do they want. So we're going to start out with an input statement, prompting them for input. We're going to say, what would you like? Let's see if we can create this menu. Now it's going to be up here where we have our enter prompt here stuff. We're going to say enter single quote S single quote, so that that S is kind of highlighted. Enter S for 6-cylinder, comma, single quote E single quote for 8-cylinder, or D for diesel engine. Now, it's not a pretty menu, but it's sort of a menu because we're giving them 3 choices. Can you see it? It's super hard to see, I know. Let me see it. If I use that viewer thing, it just makes me too blind. Get out of the way. Yeah, snipping tool won't let me zoom in either. So enter S for 6-cylinder, E for 8-cylinder, or D for diesel. And I'm not sure, yeah, we want a space after the closing double quote. It's hard to tell. If your menu is just a little bit messed up, you're going to be the one that sees it. But I want you to think about this being a menu structure, because we're giving them 3 choices and we're asking them to pick one. Now, whatever they type in, we want to put that into the engine choice variable, right? Because that's the choice they made. Now, when I click done, we should see that big message, and it might be a little easier to see there. But whatever we do now, we're ready for our selection structure. So I'm going to pull that selection structure out, and in our if statement, our condition, we're going to check to see what their engine choice was. So for this first one, we're going to check to see if the engine choice equaled, and I'm going to do 2 equal signs to do an equality comparison, if it equals the letter S. So in our output string, we had that letter enclosed in double quote or single quotes, just so it would display that way. But whenever we're comparing it in our condition clause, we have to do double quotes because it's a string. Okay, so if our engine choice is S, we want to set the price of the car up by $150. So that's going to be an assignment statement, and I'm going to put that on my yes path. So I want to take my engine cost and I want to set that to 150. So we're not affecting our total cost yet. We're just saving that in a variable that keeps track of our engine cost. Okay, let's run it. Now, if I run it, I want to type a letter S and make sure that my engine cost gets set to that 150. Okay, so I want S, and it follows the right path, and if I look at my watch window, I see my engine cost is set to 150. That's what I wanted. So everybody's okay? Okay, got it. What if our user types a lowercase s? Try it. Does it work? A lowercase s is not the same as an uppercase s. It's a different letter. So when Raptor doesn't care when we're naming our variables and stuff, but it does matter when it's an input thing. So try it, make sure, because yeah, whenever we're typing our code in Raptor, our case isn't sensitive. But for these codes, it will be. Expensive car, if I type a lowercase s, you'll see it just follows the no path and we don't get our engine cost set. What can we do to fix that so that we got the cost either way? Can we change that condition?
Can we put an or statement?
An or statement would be the perfect thing to do, right? So we could say, or our engine choice equals with two equal signs, lowercase s. So now we've got it taken care of either way, if we coded that properly. So let's try it. Now, some things that are really common for us to do as programmers, especially when we're beginning. Notice I retyped the variable name. Some people are like, you shouldn't have to. You should be able to say engine choice equals S or S. Well, the computer, at least our programming language being Raptor, is not able to handle that. It has to have the left and right side of the condition for every condition. So this condition that's before the or has to have a left operand and a right operand. This condition that's after the or has to have a left operand and a right operand. So we can't skip pieces of it like that. Does that make sense? Sometimes it seems like it's being super picky, and it is. It's real particular about that.
In newer programs, though, then and newer ones, that's not an issue, right?
Well, in Python, in some ways, you can get around it, but it still is an issue in most of the programming languages. So Python will give you guys some bad habits, but that's okay. I'll write back to you about that. Okay, so now we could try that. I feel pretty confident about it. We'll go ahead and do our next choice, and that's going to be the letter E. So we want another decision structure, this selection structure, and it's going to go on our no path. Now, if you notice, our decision structure can kind of start getting pretty deep when we're looking at our Raptor flowchart. That's what this little symbol is here. If you find this little symbol beside your flowchart, if you click it, it will collapse your flowchart, your decision body. And then if you click it again, it will expand it back out. So if you're looking at a decision structure and it's just getting too unwieldy, you can collapse parts of it down so that you don't have to see it all. We're good so far, though, so let's put in our E. I'm going to double click on our condition, and here we're going to say if engine choice equals uppercase E or engine choice equals lowercase e. Now, some things to really be aware of. Make sure you have the two equal signs. Otherwise, you're just saying to assign the value E to the engine choice variable. If you just have one equal sign, it's not a valid condition. Make sure we have double quotes, all of those kinds of things. If that looks good, click done. And if they choose the letter E, we want to assign a different value to our engine cost variable. So for the letter E, which was our 8-cylinder, we want to set our engine cost equal to, what do I want? Can't find it. There it is. Whoa, $475. Much more. Now we can just go ahead and finish out this engine cost method before we test. Let's drag another selection onto our no path. And this will be our third engine choice, which was the letter D for diesel. So in this one, our condition will be engine choice equal the letter D, or engine choice equal the lowercase letter d. Now for the diesel, we're going to set our engine cost to $7.50. And then the last thing we have is the no path there, because that was our 3 menu options. So if they don't choose any of those, we're going to output a message. Drag your output symbol to that no path, and let's output a message that says you have made an invalid selection. Now our module is complete. We have everything here that we need to calculate this engine cost part. It's doing its job. If we go this path and we end up outputting this invalid selection message, what's our engine cost going to be set to? What did we start out with it? That's right, so in your variables, what did we make our engine cost? 0. So that's an important point, because when we get to the end, we can check that and we can say if the engine cost is still 0, then we didn't get a valid engine cost assignment. So we're not going to worry about this error at this time, because we'll be able to catch it further on down. When we get to our final calculation, we'll know if we ran into an error. How are you doing? Good, you good? Can we do one more module? I don't want to drive you nuts. Do one more, you got it? Okay, we're on it. Let's do it. So let's go back to our main. After we compute our engine cost, we want to compute our interior trim cost. I'm going to get our call symbol, drag it on our flowchart. And again, I think they made this thing have the longest possible name they could think of. Compute underscore interior, but we never have to type it anyplace else. Underscore trim underscore cost. It's like an old COBOL name. Yeah, trim cost would work. Okay, let it create a tab for you. Now this one is going to be a lot like that previous one. So let's start with our input symbol. We want to prompt for which choice they want. So for this trim cost, we're going to give them the options to enter V for vinyl interior trim, C for cloth interior trim, or L for leather interior trim. Now finally, in our variable name, we're going to put that into our trim choice variable. So we've got this common thing going. We know what we're doing. We're just going to be consistent with the same logic in our program. We're going to use a selection symbol here. And the first trim choice we're going to check for is the V for vinyl. So trim choice, I had a lowercase t, which would be okay, but trim choice equal uppercase T or trim choice equal lowercase t. Whoops, V, I'm sorry. I was going ahead, getting ahead there.
I just want to my first one.
Yeah. Good job. All right, so for our V, for our vinyl, if they choose vinyl, we're going to set our trim cost variable to $50. Cheapo vinyl. $50. Now, if they don't choose vinyl, we're going to give them the option of cloth. So that'll be our second one. So our condition will be trim choice equal uppercase C, or trim choice equals lowercase c. Now for cloth, our cost is going to be $225. So it's going to be our trim cost, isn't it? I was just like, be lazy, cost. Trim cost, right? Variable name, that looks good. And then our third option for trim is going to be L for leather. So I'll put that in, trim choice equal L, or trim choice equal lowercase l. Now if it's leather, it's going to be $800. Let's put that assignment statement there. Our trim cost would be $800. And finally, if they didn't make a valid selection, we're going to use an output symbol to spit out a message and say you have made an invalid selection. Oh, awesome. Let's save everything and test here. We haven't tested for a while. We could have a mess. Now, if we're typing everything properly and not making syntax errors, then not testing every step of the way is okay because it saves us a lot of time. But it could end up costing us a lot of time, right? Because if we have some sort of typo that we've propagated throughout everything, we could end up with a lot of places to change. So we want to test often. I'm going to go ahead and test here. I'm going to put in my name. Let's see, I guess, I don't know what I want. I don't want a Honda. Actually, I do, but I think that I want something really expensive today. I want a Lexus. I want a Lexus, a BMW, something like that. I just feel expensive today. It's Valentine's Day. Should have a good, expensive car. So I want a $200,000 car. My options here will be pretty irrelevant. Okay, now my engine choice. I've tested the 6-cylinder, so I think I'm going to do D for diesel. Now, if you think of that logic chart that we were looking at earlier, to test this program, we need to test every single one of these conditions. So if we were setting up an automated test plan, which is what we'd want to do because it would drive us crazy to test every one of these conditions over and over and over, we could set up an automated test plan so that that test plan would go through and test our program. And we know that's why those kinds of things are super important, because it can get pretty tedious for us to test everything. So I know I've tested the S, I'll test the diesel option. I should see my engine cost variable get changed to $750. It did. Now my trim, I think I'll choose C, because you know I have that alpha gal, so I don't want leather even if it's expensive and luxurious. So I'll do a C for cloth. And I should see my trim charge or cost be at $225. That looks good. Let's run again and choose invalid ones.
Mine said that my trim choice was not found.
Oh, okay. We'll fix that. So try again.
It's still and the variable.
You find it?
Trim choice.
Great job.
Someone spelled choice wrong.
Now on my trim, I'm going to just choose like some invalid letter and make sure that I get that invalid selection message. And I did. And my trim cost is still set to 0. So my error handling is working okay. Trouble?
I had a question.
What's that?
Is Raptor able to support a loop where if we get the last selection, it's invalid?
Yeah, you can do that. You can do that.
Instead of ending the whole program.
Yeah, instead of it just being like, oh, you done, you lost your chance.
Yeah, that clears all your data and mistakes.
Oh, perfect.
Yeah, we can do some loops eventually. All right. Did you find it?
I just spelled choice wrong in the
Oh, okay, so you got it. Great. All right, let's do our third one. The only other thing we need to calculate or ask the user here is for their radio choice. So let's add that module. So I'm going to go to my main. Yep, add the call. This one is going to be compute radio cost. So in our compute radio cost, the first statement we have is our input. And in this one, we're only going to have 2 choices. So we're going to say enter R for AM/FM/CD/DVD radio, or G to add GPS. I'm thinking our book people just kind of didn't know what to do here. And we're going to call this one radio choice. Okay, so let's put our selection symbol in there. And we want to check to see if radio choice equals R or radio choice equals lowercase r. Now, if they pick that multifunction device, we're going to set the radio cost to 100. Otherwise, we're going to see if they wanted a GPS. So let's put our selection symbol out there on our no path. Whoops, I didn't grab it. And we're going to check to see if radio choice equals uppercase G or radio choice equals lowercase g. And if they want that GPS, that's going to be $400. in our very last thing in this module, if they did not pick either of those, they made an invalid selection. Next week we can write this one in Python. So the last module that we need to create is the one that does the final calculation and outputs the selling price. Let's test this module first and make sure we've got our radio choice working. So I'm going to run it. I'll go back to my Honda. You know, always love a Honda. And I want, I'm going to make an invalid choice on this. And then I'll make a good choice on my trim. And I'll choose GPS, I think, for my radio. Make sure I've got good choices. There's my radio cost at 400, so that looks good. Now I notice right away as I'm looking over here at my watch window that I have a typo in my selling price variable. I haven't got to using that yet. There it is. I've only got one L in there. So I'm going to leave that like that so that when we do the final calculation, I'll have some sort of trouble, right? Things aren't going to work out right. We'll see if it matters. Sometimes it doesn't matter depending on how we're using the variable. But I've got a typo there. Okay, so we want our last module to be our final calculation. So in our main, we want to add one last call. And this call is going to be display selling price. And if you remember when we were looking at the pages earlier in the chapter, they had all these modules on that hierarchy chart with these kind of names, these long names. So that's where we got them. So they had already been documented a little bit on that hierarchy chart. Very last one, you guys are amazing. Let's do it. So we're going to start out with a decision here. And we know that if any of those cost variables are still 0, we encountered some sort of error. So we're going to use those cost variables to check. So in our decision, we want to check to see if the engine cost is equal to 0 or the trim cost is equal to 0 or the radio cost is equal to 0. So we're saying if any of those things equals 0, we encountered some sort of problem as we were executing the program. We didn't get a valid result. So if that's true, let's do this whopping output statement. In our output statement, we're going to say, sorry, name, no cost for your car mate can be calculated at this time. So we're going to do some concatenation there where we're putting together some strings and some variables. Let me make this a little bigger at least. So I want to output sorry, comma, space, close string. So there's my first little string is that word sorry, followed by the comma and the space. I want to add more to my output, and what I want to add is the name variable. I want to add more to the output then, and I want to add this new string that starts with a comma and says no cost for your, and then we have a space because we're going to put the car that they picked after this. So plus car make. And then our final string is going to start with a space and say can be calculated at this time. So remember to make sure for each of your strings, you have your opening and closing double quotes, and you have a plus sign between each of those different items. String plus variable plus string plus variable plus string. So that's a monster. So let's click done and let's test that path. So we want to do one of our costs wrong. Let's run it. So I picked something bad for my engine choice so that I should have an invalid selection message. And then the others don't matter because as long as we have one wrong, we should get that output. There it is. Sorry, Renee, no cost for your fiat can be calculated at this time. Now make sure that your spacing is correct, that you've got spaces, you know, before the variables and after the variables. That kind of stuff gets picky. And let's do our final results for if everything is working. So I want to go back to our display selling price. And on our no path, we know everything was good. So let's start out with an assignment statement to calculate that selling price. We want to set the selling price to be our base price plus our engine cost plus our trim cost plus our radio cost plus our shipping charge plus our dealer charge. Now that should be all of our costs and charges all put together so that we're ready to tell them how much this thing is going to be. So we're adding to our base price our engine cost, our trim cost, and our radio cost. And then we're adding those fixed costs, the shipping charge and the dealer charge. So that should do it for our calculation. And my typo is not going to matter because Raptor is just going to create a new variable with 2 L's since I didn't use selling price in the calculation. If I had used it in the calculation, then it would have mattered and I would have gotten a big error message saying that it couldn't find it. Now let's do our final output message. It's going to go under that calculation. Now this message is again going to be long. It's going to be name the car of your dreams, your car make will cost you our selling price, and then it's going to say happy motoring. So let's put this statement out here. I'm going to try with Raptor to separate things. So I'm going to do the name variable plus, nope, it won't let me. I was going to try to go down to the next line, but it's like, nope. So our first string is going to start with a comma and a space and say, the car of your dreams, comma, your. And then I'm going to end this string with a space and add my car make. And our string is going to say, will cost you. And we're going to put the $sign in ourselves. So don't put a space after the $sign. And we want to use our selling price variable. And then finally, our last little bit of the string is going to start with a period, end space, and say happy motoring, exclamation point. It's a big one. Let's test. I want a Lexus, that's 100,000. I think I want an 8-cylinder cloth. DPS. Now, in your final master console message, you should see all of your messages here. New car price calculator. This program will help you calculate your car cost. Here's the car of your dreams and how much it'll cost you. Look good?
Are you able to go back to radio costs just for a second?
Sure. Did you get it?
Mine's not working.
Let me see what's going on. Sorry. All tangled up. Did you find it? Look at him doing this debugging, yay. Before you go, I have something for you. So let's get it first. As we start, you're seeing that even with a Raptor flowcharts, you have to do some debugging, figuring out what your problem is. And you guys have done a great job of seeing people turn to each other and help each other with things. It helps so much if you can tell somebody else what's going on in your program. And even if they don't know what you're talking about, somehow just telling them about it, torturing them, helps you figure it out and you can find your problems. So with that idea, a few years ago, they came up with this idea of rubber duck debugging. And this is where you have just your rubber duck and you talk to your rubber duck about your program problem so that you can figure it out. So we like to give everybody a rubber duck for their different programming classes. So this will be your 120 rubber duck. And I have this whole big pile of new rubber ducks, so you'll have an optimum choice. So come on up here and get one so you're ready to do your debugging. Because next week we start Python.
Chicken T-Mobile pizza.
My husband had to keep one, so I had to open them before I got him here. He was like, I want that. Oh, he wanted one. I was real close to that. I was like, take it, duck. Now you could get a whole series of them. Some people have them all in their backpack. Some people have some ducks at home. Some ducks they take with them. Some ducks they do different things with.
The hands-on exam, I submitted it, and now it's saying I never did, and now it says it's missing.
So to see what
It won't let me since it's overdue or whatever.
Oh, I thought I fixed that. When did you try?
I tried. I submitted it last class period.
When did you try again?
I just tried today.
Oh, just now.
Yeah.
Okay. Because I thought I took that stupid end date off of there. But
Yeah, I
must
checked my
not have
grades
done
and it
that.
says missing. And
Okay.
I'm like, that's kind of weird because I submitted it, but I guess it
Well,
never went through.
something might have gone on with Canvas because there was a bunch missing.
Yeah, essentially.
They never tell us a lot of stuff. It's like, we're not supposed to tell you guys. I don't get it sometimes. I'm like, we're using technology. We can all deal with it. Okay, let me take that. No, that's not the right place. You better get him one too, unless you think he's going to start rubber duck chewing.
He would destroy it, and then
If he was allowed.
He'd probably find anything else.
He's like, come on, I really need a run.
Yeah. They'll get a hold of his.
Yep, it's closed. So darn it, I thought I had that fixed. I'm so sorry.
That's, no,
I just
my
was like,
fault for
didn't
getting
want
it
to.
all the way up.
No, I just. Some semesters it's good to close things. So you have people that aren't very responsible, but then other semesters it's a big pain. Okay, it should let you down. So, okay, did everybody get one? Got your rubber duck so you can solve all your problems. Get out here, have a great long weekend. I think I gave you enough work, like I said, to read that chapter.
Read the chapter and do that's in chapter 4.
Oh, huh? Sure. Submit what you can and I'll do it. Which, so I unlocked Zone. So let me know.
I mean, I'm literally gonna be spending all weekend trying to catch up, so that's I promise I'll make to you.
Okay. Well, let's see. So focus on these ones that aren't closed,
Okay.
because that should be plenty, it looks like.
Well, I just want to catch up. And,
Yeah. And let's see how that goes.
Sorry.
No, that's okay.
I'm
You'll
very
get good at it.
detail. I know I'm very good at detail, but I'm not suck at typing.
You'll get good at it. So yeah, focus on the ones that are still open, because the ones that are closed are a bear for me to go back and regrade.
Okay.
So let's see how it goes with those ones that are still open, and then if you feel like you can do some of those others too,
Okay. Yeah.
we'll open them for you
Okay.
to
I'll
see.
just email you if I can, or if that's fine.
Yeah, that's
Okay.
fine.
All right.
No,
I appreciate it. Thank you.
No problem. Good luck.
See ya. Have a good weekend.
Gonna take to finish that because I have
That
close
test,
to 2 hours.
how long do you think you need for that test? And I want to say you guys took like the one you guys took the other day. I want to say like 40 or 50 minutes. That's what pretty much it seems like everybody starts getting done.
Maybe
30,
with the hands-on one, I took
a little longer.
What is that,
You'll
like
have to
pseudocode
find
and
it.
flowchart?
It's a flow chart.
It's a flowchart.
So you'll have to find Raptor over there on the S drive.
Okay.
Remember where we went and got it.
Yeah.
So you'll be able to find it there. And I put in that, excuse me, I put in that test request, the makeup request, that you guys would have to access the S drive to get to the Raptor software. So they shouldn't think that you're trying to do anything
Okay, so
untoward there. But
so we're doing the flowchart with Raptor.
uh-huh. And so save it and then upload it to the test for that last question.
Can we just do that on our own time at some point?
Anytime the testing center is open today.
Oh,
So
okay.
I just set it up for today. So just make sure you get it taken care of today. But yeah, they're pretty flexible.
Okay.
So anytime.
Thank you.
Good luck.
Thank you. I think you took it to the instant before I got here. I got your data too.
Did you sign in?
I sent the sheet back.
Because I actually didn't today. So it should be okay. I think we should be okay.
All right.
Let me double check.
think I forgot.
My phone just sometimes is totally overloaded and I really don't know. Okay, good. I don't know, look at you. I hope it wasn't- it's hard. He looks really scary. Not that in the state. Do you know how to use it yourself?
Has to be a certain height, too. That's funny.
Nobody knows how. Bites are back.
There she is.
I'm hiding.
Yeah. I was like,
Hiding.
Is this like your office time?
Uh-huh.
Can we keep that working here?
Sure.
Okay. So I went to the library and like everywhere school. So.
Oh, wow. Yeah, you're fine. Sure. How are you going to present tomorrow? My question being, how are you going to present tomorrow?
I have no idea.
So, do you want to use one of the computers here? Do you want to use your laptop?
I want to play my game.
Uh-huh.
Well, I think it's okay as long as it's if they just want to like if I'm not showing any of the code or any of the projects, I think any computer can actually run the
Okay,
game.
good. So you don't think that'll be a problem.
Yeah.
And then you guys, you're going to use the computers here. You too? You're going to just use computers here.
Yep.
So I don't know who. I just was wondering if we needed any special cables. I think we're in pretty good shape. This thing will make it a lot easier than that old projector
Yeah, I'm sure.
because it should run a lot better. We just have a lot more options with it. Hi.
We have this classroom schedule from 10 to 11. Are you guys using it?
There's Career Center students here till 10:20. I think they figured out their problem yesterday. I don't know if you've heard from the
I have not
scheduler
yet. No,
person.
I'm sorry.
That's okay. No, we're causing all sorts of trouble. Apparently, they didn't tell the scheduler lady that there were career students here. I can send them off someplace else.
No, it's okay. It's okay. We will give it to the room. This week is a good time.
See what's going on.